Hi everyone. Today we're going to see about concrete properties. Concrete properties. There are many properties in concrete, mainly focusing on strength, durability, density, workability. In that we're going to see about strength. Strength means concrete is strong in compression but weak in tension. Concrete has a high compressive strength. It can withstand heavy loads. It is mainly weak in tension. The strength of concrete mainly influenced by various factors such as mix design, curing conditions, quality of materials, and poor workmanship. These are the main important factors considering the strength. And then durability. Durability is the another important criteria for concrete. So concrete is known for its durability and resistance to mainly for weathering and chemical attack and abrasion. Then another important property is about density. Density of concrete plays a major role because nowadays we are using a lightweight concrete. For example, lightweight concrete contains uh, the strength of the concrete also increased. And in lightweight concrete, the density is considerably reduced by using we are using lightweight aggregates. So for that, the weight of density will be considerably reduced. Then another important property of concrete is about workability. Workability is nothing but workability. If the workability is good, the concrete is okay. If workability is very poor, means the strength of concrete will be considerably reduced. Then another important factor is setting and hardening. Concrete undergoes a setting process during which it transitions from a plastic state to hardened state. Uh, the setting time is very important for the concrete, and the hardening stage also. The hardening stage is mainly influenced by some factors such as the temperature, humidity, and the type of cement we are using. Then another important factor property is about shrinkage and creep. So concrete experiences some shrinkage as it cures, which can lead to cracking. So creep is also an important factor. Creep is the deformation that occurs over time. It's mainly time dependent. Another important property is about fire resistance. Fire resistance is nothing but concrete is a fire resistant, providing a protective barrier in the event of a fire. Its mineral composition allows it to withstand high temperature without losing its structural integrity. Then another important property is about sound insulation. Concrete provides good sound insulation, reducing the transmission of sound through the walls and floors. And another important property is about permeability. The permeability of concrete plays a major role because permeability of concrete can be controlled through proper insulation and curing. Low permeability is desirable for structural exposure to harsh weather conditions or aggressive environments. So when we are going to see about setting and hardening. First, we are going to first setting. Setting of concrete. Setting is the first stage in the hardening process of concrete, during which the concrete changes from a plastic fluid state to solid, but not necessarily hard. Setting begins shortly after the concrete mix is prepared and placed. It involves the chemical reaction between water and cement, resulting in the formation of CSHL. It's a very important criteria for setting. The initial setting is marked by the loss of plasticity, making the concrete unworkable. Then hardening. Hardening is the second stage in the concrete during process, during which the concrete gains strength and become more rigid. Hardening continues after setting, and the chemical reaction between water and cement progresses further. As hardening progresses, the concrete undergoes a significant increase in strength and durability. What are some factors influencing setting and hardening of concrete? The first important factor is temperature, water cement ratio, types of cemeteries, and admixtures. These are the following factors influencing setting and hardening of concrete. Transition zone in concrete. Transition zone in concrete refers to a region near the interface between the cement paste and aggregate. Mostly the cement particle and fresh concrete cannot pack together as efficiently when they are in closely vicinity with aggregates. Elastic behavior in concrete. The stress strain curve is very important in the concrete. Mainly elastic behavior is the ability of a material to recover original shape after the source is removed. Uh, we already know about Hooke's law. Within Hooke's law, stress is directly proportional to strain within the elastic limit. Then creep. Now we are going to see about creep. Creep in concrete refers to time-dependent deformation or strain that occurs in structure under a sustainable load. Some factors mainly influence creep in concrete, that is concrete mix proportions, cooling conditions, and age of concrete. Shrinkage. Shrinkage in concrete refers to the reduction in volume that occurs as the concrete undergoes a decrease in moisture content. Here also it's a common phenomenon that takes place during the drying and curing stages of concrete. Here also some factors influencing shrinkage in concrete. This water cement ratio plays a major role for the shrinkage. Then aggregate type, we are using different types of aggregates. So aggregate type, then based on size and type of aggregate, then curing conditions, then admixtures we are using. The types of shrinkage we normally know is a plastic. First type is plastic shrinkage. Plastic shrinkage occurs mainly during the initial setting and hardening of the concrete. It's the initial state. The rapid evaporation of water from the surface of the concrete due to factors such as high temperature, low humidity, and wind can lead to plastic shrinkage. It's a starting process. Then drying shrinkage. Drying shrinkage occurs as the concrete continues to cure. It's the second level, cure and harden over time. Then the primary cause of drying shrinkage is the loss of water from the hydrated cement paste. This process can extend over an extended period, contributing a long-term shrinkage. Some thermal properties. The important thermal properties of concrete that thermal conductivity, specific heat capacity, thermal expansion, thermal diffusivity, then freeze thaw resistance. These are the important properties. Mainly, the thermal properties of concrete is mainly focus on thermal conductivity. Is mainly focus on conducting heat. Then concrete typically moderate to low thermal conductivity. A specific heat capacity is nothing but literally deals with high heat capacity, high specific heat capacity. Mainly is absorption of heat. Thermal expansion is nothing but due to temperature fluctuations. Thermal diffusivity is nothing but how quickly heat can move through the material. This is very important. The next is strength porosity relationship. The relationship between strength and porosity in concrete is a critical aspect that affects overall performance and durability of material. Strength porosity mainly affects the durability of concrete. Porosity refers to the presence of voids or open spaces within the concrete mix. So pore structure is very, very important and it plays a crucial role in this strength porosity relationship. Then permeability of concrete. Permeability of concrete is very important. Permeability is a crucial property of concrete. Mainly, it allows its ability to. The permeability is nothing but the ability to allow water to pass through its pores. Low permeability in concrete structures enhance durability, resist moisture ingress, and protecting reinforcement steel from corrosion. And some of the several factors influence the permeability of concrete. First main thing is water cement ratio, then curing conditions, quality of aggregate you are using, then admixtures we are using, then cement type, compaction, then pore structure, then age of concrete. These are very important factors that mainly influence the permeability of concrete. The permeability of concrete, we already have water cement ratio. So water cement ratio plays a major role. Then it mainly influence the permeability of concrete. Higher water content generally leads to increased porosity and permeability. Therefore, we are reducing the water cement ratio through proper mix design can significantly enhance the impermeability of concrete. In curing condition, proper curing is very, very essential for the development of concrete strength and durability. Inadequate curing may really results in porosity and permeability. Aggregate quality, type and quality of aggregate we are using is very, very important. Well graded, dense aggregate with a low water absorption property aggregate we mainly are going to use. Then admixtures. The use of admixtures plays a major role. Then it will mainly affect the permeability of concrete. So superplasticizers and water reducers we are using in the concrete is very, very important. Then pore structure and water transfer process. Pore structure of concrete plays a significant role in determining the permeability and water transfer process. So very, very important three factors: capillary pores, gel pores, entrinded air voids. These are the very important factors for the pore structure and water transfer process. So water transfer process is nothing but the water transfer process involves several mechanisms, including first absorption, permeation, and diffusion. Absorption is nothing but factor mainly depends on porosity, pore size distribution, and the surface properties of concrete. Then permeation is nothing but the movement of water to the concrete matrix. Then diffusion is nothing but movement of water molecules within the concrete